Okay, in this video, I'm going to show you how to do some calculations for your egg drop device analysis. So I'm going to use an example here. My egg drop device that I created many years ago had a mass of 226 grams. Of course, my equation up here is going to require that we put that in kilograms. So I divide that by 1,000 to get 0.226 kilograms. The egg drop device that I created is very box-like. It had a height of about 12 centimeters, and each of the sides was about 15 centimeters in length. So in this equation up here, I need to do a height plus the perimeter, and I need to put those in meters. So the height would be 0.12 meters, and the perimeter would be the sum of the length, the width, the length, the width. That'd be 15 times 4, so that'd be 60 centimeters. Or in meters, it'd be 0.6 meters. Okay, so height and perimeter is needed there, as well as the mass in kilograms. Now, the average collision force, I'm going to go ahead and change color here to red. One of the things that you're going to have to calculate here is just what that force of collision is. Now, that depends largely on how massive that egg is, as well as its impact speed. So before I can calculate the force of the collision, I'm going to try to calculate the impact speed. So I'm going to go ahead and switch that over to blue and see if we can't calculate that. So when the egg drop device fell, it accelerated due to the gravitational attraction to the Earth, and it hit traveling at some speed that I'm going to have to calculate. For my example, the drop height was 2.3 meters. It was accelerating at a rate of 9.8 meters per second squared. And what I want to do is I want to determine how fast it hit. So what was its velocity on collision? Now, I'm going to have to do that using two different equations. Let's keep it in blue. Delta y equal to 1/2 gt squared. That's the equation that relates how far an object drops when it's accelerated through a gravitational field, and that's based on the time that it's dropping. Okay, so I know for this one, it fell 2.3 meters. I'm going to use 1/2 of 9.8 will be 4.9, and I'm going to try to solve that for t. Now I'm going to put a little subscript here. That t is the time of the fall. So that time of the fall is different than the time of the collision. So we have to make sure that we don't mess up those two quantities. They are different amounts of time. So it took a certain amount of time for it to fall. I'm going to calculate that with this equation. So 2.3 is equal to 1/2 of 9.8 is 4.9. And then I have to divide both sides by 4.9. And then take the square root to get the time of that fall. Calculator can give that to me. And I'm getting about 0.685 seconds. So that's how long it took for the egg drop device to fall. Now, how fast is it traveling? Well, how fast it's traveling is going to be found using this equation. Again, a part of the very first part of our unit here, we looked at free fall and the acceleration due to gravity. So we're going to now use those equations from the first part of this unit. Delta v is equal to g times t. It started from rest and it hit at some velocity of the collision that we're going to try to find. Well, it was accelerating at 9.8 meters per second squared, and it was falling for 0.685 seconds. So I just simply multiply those two numbers together, and I get that its speed of impact was about 6.7 meters per second. So how fast it hit that ground? If it fell from 2.3 meters, 6.7 meters per second. So that up here, 6.7 is this number there. Now, in order for me to find the collision force, I'm going to use something that we covered in the second half of this unit, and that was the impulse momentum theorem. So I'm going to go ahead and switch that over to red. The impulse momentum theorem says force acting through time, that's impulse, is equal to the change in momentum on that object. So let's go ahead and write that. Force of the collision multiplied by the time of the collision, it's different than the time of the fall, I've got to be careful with that, is equal to m delta v. Now, the time of the collision is found through that counting of frames. For my example, it took 4 frames for it to come to a stop. Now, my frame rate is 240 frames per second. So if it took 4 frames for it to stop, that would be the time of the collision would be 4 over 240 seconds. That's 0.017 seconds. So it's a very sudden stop. Hence, that force is fairly large. I should get that color that I'm looking for there. I think it's red is what I'm looking for. There we go. Okay, so 0.017 seconds for it to come to a stop during that collision. Now, importantly, I'm interested in the force of collision on the egg, not on the device. I'm not so concerned about the mass of the device here. I'm concerned about the mass of the egg. So the mass of the egg, 60 grams. I'm going to put that into kilograms, and then I'm just going to go ahead and solve that for the force of the collision. So we're running out of space there, so let me move this over just a little bit. The force of the collision equal to, let's see, m delta v divided by that time of the collision. Now the mass of the egg, pretty much all the eggs about the same, 0.060 kilograms. Now the change in velocity, it hit at 6.7 meters per second and it came to a stop. And so I'm going to go ahead and put that change of velocity in. I can put it in as a negative 6.7 meters per second. The negative denoting that it was in the upward direction, it was slowing down. You could put that in as a positive and still get a decent value for your force. It's just the negative there would denote that it's an upward kind of force. Now I'm going to divide that by the time of the collision. The time of the collision is very small, 0.017 seconds. Now when I go through, my calculator can give me the answer that I get. Numerator is 0.402, so negative 0.402, that's the change in momentum that the egg experienced. It'd be 0.402 kilogram meter per second. And that change in momentum occurred over 0.017 seconds. So I divide that now by 0.017, and I get a collision force of about 23.7 newtons. Now I could call that negative if I'd like. The negative is denoting an upward direction. I can go ahead and keep that as a positive for my ME score, just so that all my numbers turn out to be positive there. Now that 23.7 would go into this portion of the equation up here. Okay, so I've calculated now both the impact speed and the collision force. Everything else can be calculated just by putting in your appropriate values based on your egg drop device. Okay, I hope this video helped you.